All right, great. So for today, we are going to dive into the Texas 2021 Blackout flow. And so this flow I've gone through quite a number of times to date. And there's a few things I want to highlight in terms of the design of the storyline that I think lends itself towards this story, but work for a series of other stories. I think this is a great example of sort of looking back and going through the timeline of something happening and iterating through time in an iterative way to help explain a story, as well as showing how multiple variables can update together over time. So the very first thing that we dive into, and maybe what I'll do here is I'm just going to quickly highlight sort of the unique aspects, and then I'll go through the story, and then we'll actually dive into rebuilding at least the above and below freezing with today's data. So one of the first things I start with is actually this frequency map, where we look, and the idea here is to sort of give a foreshadow of what is to come, that understanding the alternating current frequency chart here sort of teases the idea of being embodied in that situation where it's 9:20 in the morning and the power is starting to have all sorts of issues on the grid. So you feel the emotional journey. And so it's just setting up that teaser in the very beginning that I think sort of sets the theme for what is to come. So it's really more just foreshadowing the beginning and setting up that larger context of how ERCOT is different. So you have the situation in mind, and you know something is coming with the frequency. You just don't know what it is yet. So some of the other components here that we'll dive into is the multiple axes and seeing that over time. But one of the key components, or one of the key sort of, I think, emotional moments is this step, where you see the true magnitude of the price increase, where without updating the axis, going from 0 to 300, which is the normal range, you can really see a sense of scale. And I think that is sort of another way you can show magnitude in a story, and that applies to numerous story types. And so some of the other elements here are just really looking at things through time, and then revisiting the thing we started with, which was that story of frequency, and going below this threshold, where going below that threshold is actually causing damage to equipment. And so it's, I think, embodying the data is sort of what was the intent with this little section of steps, where you're imagining yourself in the control center, having to make the decisions of what to do and which customers to turn off. And so as you walk through this timeline, going through that step by step and feeling the anxiety provoking nature of when the frequency dropped below this threshold, and you're basically 9 minutes away from a complete blackout, and waiting that 4 minutes before the power goes back up and they're able to increase it. So those are some of the components just to sort of watch out for, because I do think those are sort of some unique characteristics that can very much be applied to a whole slew of different flows, where you start with an idea and you revisit it towards the end to really hit it home, that you use the magnitude of these lines to help show more empathy and understand sort of a feeling, and then being able to show multiple time series data in a row, all with one axis, allows you to sort of see the progression of events and how one variable influences another. So before I dive in a little further to actually tell the story, any questions or additional commentary on sort of the key design features of this flow?
Yeah, I've got a quick question, Michael. And that is, when you were researching building this story, I mean, had you latched on to the importance of that chart on the right prior to building the story, or did you kind of discover it as you were going through it?
I sort of discovered it as I was going through. Great question. And the thing that really struck me was I didn't realize how close Texas really was to that threshold. And it was someone else's reporting on the situation, basically talking about the 9 minutes, that really sparked my interest in sort of the subject, hence why it sort of was there. In many regards, this was actually through a lot of iterations. I think I originally had a different visual of how to describe alternating currents, thinking about it like the voices inside of a stadium, if they're all harmoniously going together, and then some people are off, that it starts to throw things out of whack. But yeah, so that's sort of the intent there. And yeah, so yeah.
Yeah, okay, yeah, and that kind of mirrors my experience as I'm building these flows that I'm building. I get out of the blocks and I visualize some data, and I see some things, and it kind of leads me to the next step and the next step. And then more often than not, somewhere while doing all this, there's a really interesting epiphany that I have that kind of enlightens me about one other thing that really needs to be shown.
Yeah.
So I've kind of grown to believe that's just part of the process. And it's really hard to figure out everything up front.
Yeah, absolutely. Cool. So let me go ahead and I'll just go through real quick here the story itself, to watch out for sort of these components, and then we'll actually go through. And as part of this rebuild series, the intent is to take the final output, which is this guy, and it's sort of almost like a monstrous amount of information here, all in one flow, and that typically people are editing this. And so what I've done is extracted all of the data and put it into a public folder, calling it rebuild series. And I'll actually start to go through step by step the things that we did to get to what you see today. And so that means going to a website to find the data, loading it, and then doing some transformations and some other steps here. So we'll really try to be comprehensive in rebuilding these, and try to clear up any sort of mysteries involved here. So let me go ahead and I will share my screen this way. And so, ultimately, I was shocked with the 2021 Texas blackout to learn that it cost more than Katrina. It cost the lives of 70 people, and was actually 4 minutes away from a way worse catastrophic failure that would have left Texas out of power for, I believe, more than a month. And so to understand this story, you need to understand that if the frequency of the alternating current that comes into your house, the electricity, if it falls below this threshold of 59.4 hertz, that's actually starting to cause damage to both the generators, the power generators, as well as any AC electrical motors that are on the grid, that it's all magnetically coupled. And if it comes off that frequency, it's actually causing damage. And so there's a fail-safe built in, that if that happens for more than 9 minutes, it goes offline, so it doesn't cause more damage, which would render all of the generation capacity not possible, which would be even worse. And so the other thing to understand is that Texas is its own grid. There is the Eastern Interconnect and the Western Interconnect in the US. So that's what you need to know to understand this story. And to understand what happened during February 10th through the 20th of 2021, we're going to look at the temperature in degrees Fahrenheit, demand, the supply of electricity, and the price of electricity in US dollars. So at the very basic level, it got cold. It's typically in the 50s in Texas during this time. And you can see that on average, it actually went below freezing starting on the 11th and continued to go quite low. And during that same time, people are using more and more electricity to heat their homes and for other means. And lastly, that's on the supply side, we see the 100% capacity. So 108 gigawatts total are in the system. Right now, we're demanding up to 72 here. So there's more than enough capacity in the system. And it was on that first day that we saw the first loss of generation capacity. So at full capacity, which was at the very start, it's around half gas, 30% wind, and then coal, solar, nuclear as the other components that make up the energy supply. And as we play this forward, that first day, we see a loss of capacity for wind generation, going down to 61% capacity. So now it's at 94 gigawatts total, but that's still plenty in terms of being able to supply the demand. So as we play this forward, it's things are fine, quote unquote. But I think what you can really start to see is that the demand keeps going up and supply keeps having more and more constraints. And because this is a capitalist and free market economy, the price of electricity helps show that demand and supply mix. And so at its peak here on the 12th, it went from $30 on average for a megawatt to $300. And then between the 13th and the 15th, we see just how high that price went, to incentivize producers to create more electricity, because people will pay anything to get that electricity that they need to support the demand. So it doesn't matter how much the electricity costs to generate it. So it actually jumped up to $7,000 to try to incentivize producers to produce more. And so then it was on this evening that disaster sort of struck. And it's really this sharp decline in gas capacity that, because it's such a large component of the overall grid, that large decrease really had a ripple effect. But it wasn't just natural gas, it was all these other components as well that had some decreases, even with one nuclear facility actually going offline. And so, to revisit that evening, let's go back into the heart of the operations where they're maintaining the frequency of the alternating current and making decisions. And the thing that to note is that anytime they turn off customers, that has the effect of helping keep the frequency up. And anytime a power plant goes off, it has the effect of dropping the frequency. And so they're basically continuing to balance these two, where they have one power plant go offline, they have a few others, and this trickle effect. And then at 1:51 in the morning, they actually went below that threshold. And so that timer starts, the 9-minute timer. And so it was at 1:51 in the morning that they turned off 3 gigawatts total worth of customers, which is, I think, the second most in history in terms of the number of customers turned off. And it quickly then escalated, where 4 minutes later, there was still no net impact. And so they turned off 3.5 gigawatts worth of customers. So very large swaths of Texas being turned off. And that did have the effect of reestablishing the frequency and saving sort of the machines that are on the circuit. But as a result, they had to turn off customers so they didn't have electricity. And so it's this little component down here, this little bit of red, that is called load shed. Demand that was there, but they couldn't supply. And so the customers that are turned off, essentially. And so it is that component that is the disaster. It affected 4.5 million customers, cost 195 billion in damages, 70 deaths. And it's all in these 3 days where they weren't able to create enough power. And that's on the price side, you can see it goes all the way to the max ceiling of $9,000 to try to incentivize producers to produce more electricity. So things do reestablish themselves and sort of come back. But, in many regards, this picture of what happens in Texas became a lot of sort of finger pointing. That on one side, people pointed to the windmills or the wind power, and that froze up, and that's why all this happens. And I think as you can sort of start to dive deeper here, it's a mixture of a lot of things. A mixture of what happens when it's a truly free market economy, and that there's these stories of customers that had variable pricing having to pay exorbitant amounts for these 3 days of power. And yeah, so anyways, I think this helps give you a sense of the big picture of what happened in Texas during the 2021 outage. So that's the story, and those were the sort of key components that I think are sort of unique to this story, but can definitely be applied to many others. And so now the fun part of dissecting this and sort of rebuilding the components. So let's start with temperature, because that's easy to understand as well. And understanding that will help us build all of the other ones. So I'm not going to go too in depth on this one, because I do think we'll probably have to dedicate some additional time to build all of them. But I'll share the link to this folder, but essentially this website, and I'll put these links into the right document, etc. This is actually from something I came across on Iowa State University's sites, but it allows you to find these weather stations more or less and download temperature data or some other information if you'd like for specific date ranges. And so the thing to do was basically to select a few cities, so like San Antonio. I think I also put Dallas in there. I'm not going to be too specific here, but basically you're selecting which stations to pull from. You're telling it to look at the air temperature, and then we're going to look at a specific date range of 2021. I believe it was February 10th through February 20th. And so by committing to sort of that time frame, we can essentially get the data. Let me go back here. I want to actually save it on my computer, so it saves it as a CSV file. And I've already taken this data and basically brought it in, but it looks like this. It's the station ID and the temperature. And so from that, you have to add a little bit more. So I brought it into Google Sheets. Oh, sorry. There was also latitude and longitude available in the download type. I forgot to mention that. And that is just this little dialog box to include latitude, longitude. So just additional info. I don't think it's really used, but from this is the data we had. And so then there was some things to do. What thing you'll notice is that in this PEXIS power outage, I think it actually works really well to show the freezing line. The freezing line is the thing that matters. I could show you the temperature, but you really care, was it freezing or not? And that's sort of the key thing that's being highlighted here. And so in order to do that, the way we do it in Flow is that it needs to have an axis at 0. So it needs to know what axis to draw to. So the mechanic to do that we'll get into, but in order to facilitate it, we need a column that basically says above or below freezing, how much. And so that way, if it's 10 degrees above freezing, we can show that graph appropriately. And then so I'll show you sort of how we do that when we get a little further. In addition, these station IDs are not understandable. So translating them back into the city names just from the original download where it says what stations go to what was also added. And then this last one, I personally think makes it easier as opposed to saying a date range as the main variable that you update. So normally when I look at time series data, I'm looking at the 10th through the 19th, and that I could basically set up steps so that I have a filter in place to say less than the 13th, and it'll show me that data, and then less than the 16th. And I can do it that way, putting in the dates. One thing I've found sometimes just easier to conceptualize is just number of days since the start. So to do that, it's actually not that hard of a calculation where all you need to do is take the existing date that was there and subtract the date of the first day of in this case, the February 10th. And so now everything is days since midnight of February 10th. And so one day later, here would be the 11th. And so this variable now just becomes, days since midnight, and that's easier to, in my mind, at least, to conceptualize and iterate through, as opposed to always having to think about, oh, what day did it start? Then, n+5, etc. So personal preference, but something that is, I think, valuable. Then I added one last column here called states, and that will make more sense in a second here, because in this new rebuild series, we can leverage some of the new techniques to build this. And so one of those techniques is to use snapshots. So I will pause here in a moment before I get too far down this road. But essentially, this is the end output that we're hoping to make, where we see the different cities and their graph from above or below freezing. And the more we'll add into this. This was just the start of it to rebuild. But that's essentially the next step of this process, is to load in this data and start to rebuild what you see here as the above and below freezing line, and making it look like that. So before I move further, what questions do you guys have, or Bills, or anything else?
Yes. So did you
Comments on?
take the average of the San Antonio, Dallas, and Austin temperatures and define that to be the temperature that you show in that chart?
That's right. Yes. Actually, originally, this had a lot more complexity to it. There was actually a button. The idea being that when you click the button, it goes from this level of information to the next level of detail. So it expands out in the depth axis, and you see the different cities. And then you push the button again, and it goes back to just the state average. So that was sort of the original intent, but we took out the buttons because that was just too much detail. But I did think it was kind of an interesting mechanic of, you know, I called it a drawer mechanic. Like you pull out the drawer to see the details, and then you put the drawer back in to re-summarize it. Is sort of the
Yeah. Yeah. Okay. So it kind of feels to me like this is going to be close enough to being an accurate reading of what the state average is. You know, maybe
right.
by the time you take into account Houston and some other areas and population and the like, the weighted average might be plus or minus a couple of degrees, but the shape of the curve is going to be correct.
That's right. Yeah. And there are other ways to get the average for the state, and we can definitely be more precise there.
Yeah. Okay.
But I think part of this is some of the power of basically the aggregation that we've built in to the platform now, so that you can create a snapshot where we say just the state of Texas, and then we have all of these averages sort of predefined for us, and we can leverage those. So,
Okay.
yeah, that was sort of the intent. In many ways, it's kind of fun to revisit these older, or these flows that were built, because we have some newer techniques that we didn't have back then. So it is kind of fun to look at. And maybe for your edification, Bill, one thing I'm thinking about is more or less using variables to update the time here. So as opposed to you seeing a million steps, if there was a way with the node editor that we had the ability to play time in a more different fashion, I think it could work well. So yeah, that was more or less what I wanted to go through today. Now I know Stephen had to jump, so I can go in and actually start to rebuild that temperature graph. Or I could pause here and sort of save that for sort of the next lesson. What do you think?
Yeah, well, we're about half an hour into it. I mean, your choice. We could either go 10 or 12 more minutes, and if you think you get through that checkpoint in that time, or if you want, if you think you can't get through that checkpoint, then it'd probably best just to stop here.
Yeah. Why don't we do this? Let me do just one more step here, and then we'll pause. I'm not going to complete the whole thing, but at least for this graph, let me just start this over so you can sort of see from a fresh perspective, how do we get here? So let me go ahead and start this flow. So this is the Google Sheet. And from that Google Sheets, we are going to bring that data in. So I'll create a new flow by clicking Create New. And then once that loads, I'm going to select /upload, change it from CSV to Google Sheets, and actually import this data set. And so this will import the data just like we had it in the Google Sheet, where we can see the different stations, the city, days since midnight, etc. And the first thing I'll show is just building that first scatter plot. So the on the chart, we'll change it to a scatter plot. On the width axis, we're going to put time. So we can do that two ways. We could do the days since midnight, or we could actually do the time. And that's actually called valid. I think in the data set, it probably should rename that to basically be dates. So let me do that. And this is a good example of me making a live update here. And if I want to see that reflected back in the flow, I will hit this refresh button, and refresh will repull the data from that Google Sheet. And now we have date. So I can say date. So Google Sheets definitely makes it much faster to loop back to the data, add a new column, things like that, which are definitely can come in handy. So on this scatter plots, the height axis I want to be the temperature in degrees Fahrenheit. Actually, I take that back. We don't want the temperature in degrees Fahrenheit. We want the above or below freezing. So you'll notice the curve looks exactly the same, but where 0 is different. And so from this, we have the 3 lines. And so let's actually, I'm going to color it a little differently than what I showed. So on the depth axis, I'm going to include the different cities. So here we have Austin, we have Dallas and San Antonio. And if we add in a connection line by clicking new connection, we can connect these dots together based on the station or based on the city, same thing. And we see these curves. And the thing why we set the 0 point there is very specific, and that's because we want to change where the axis is. So if I go into axis options, there's an axis origins at 0 mark. And what that does is makes the plane at 0 as opposed to at the base, wherever the minimum is. And so from there, what we can do is add in some connections. And these connections are sort of the reason why we did this is to create connections that go to axis or map. And so now we see the lines going to that 0 mark. And the thing I want to really emphasize is like above or below. And so one way we could do that is to change the colors so that it's a gradient scale based on the temperature above or below freezing. And I can make that range quite close to 0, so -1 to 1. And I personally like sort of indicating cold as blue and warm as more of like a green color. And so that way, sort of at a glance, you can see the temperature go down. And one thing I'm going to do here is I'm going to make this, let's do -35 to +35 degrees, or sorry, 35 above freezing. And the reason I'm doing that will make sense in just a moment here. So this is above or below freezing, but if you notice back in this graph, I don't show that. I show just regular temperature. This is at 32 degrees. So how do we do that? That's this next step. So the thing you want to emphasize is to make sure to get this into like a pretty good format. And to do that, I'm going to decrease the size or the height just a hair, since we're going to be stacking graphs on top of one another. Having each one of them a meter tall would be quite a lot. And so keeping these a little shorter so that they can actually stack is important to define. So now we have this. I'm going to make it just a little less deep since we don't have maybe more than that, 0.75. Many attributes. And now that I have this set, I'm going to duplicate this form. So now I've taken this form and I've put it smack dab on top of it again. And the reason I'm doing that is that I want to change the height axis back to the temperature in degrees Fahrenheit so that this axis is actually correct. And if you recall, the thing I want to go to is -35 to +35, which I need to add 32 to. So it'd be -3 to 65. And now I know that this axis actually is going to show the same things. For whatever reason, it's axis is not at 0 for this one, or for this second axis rather, since that's not there. So this will make more sense in just a second. So these are on top of one another, which is why it's hard to see. But if I remove the first swarm height axis by going into the first swarm and then going to axis options, show height axis, I can turn off that first axis. And so now I'm left with the degrees in Fahrenheits on the other graph. So some of the other things to possibly do here is to turn off the grid so that we're only using this the second swarm to really be the formatting, and that's basically it. So I'm going to turn off the depth axis. I'll turn off the width axis, and actually I should have turned off everything on this one. And then on the other flow, I'm going to keep on the grid as reactive. And that way we end up with a structure that looks like the axis is part of this first swarm, but it's actually a component of the second swarm. So a little tricky, I'll admit, in terms of like some nuance there. One other thing to sort of mention is that you probably want to make the size of the dots very, very small so that it does not interfere with the first swarm, which is the main thing that has dots on it. So a little bit of a workaround in terms of updating the axes lines, but this sets us up for success to basically build off of this. So at a very high level, this is sort of rebuilding that graph, and that we'll get into sort of the next step, which is I don't want to see the cities. I want to see just average those all together. What was the average? Because I don't need that much detail. And that's sort of the next step where we can actually use snapshots to help aid in that process. Whereas before, I just created a line that showed I just did the calculations and just showed that. And I also showed the historical average in the data as well. So we'll cover how to do that. Yeah, so anyways, kind of fun to revisit some of these components and, revisit how you go from the raw data, from a website to the actual data and some of the calculations to then visualizing it and iterating on some of the loops. So yeah, any other points to make here, Bill, or things you'd like to add?
No, I don't think so. I think I followed what you're doing there. There was one little nit. I think did you set the temperature range on the second chart from -3 to 65?
I set it from, so the first graph goes from -35 to
Right.
+35.
Right. Yeah.
And so that is
Yeah,
above or below freezing, which is,
yeah, I mean, it should be -3 to 67. And I thought I heard you say 65, and I have no idea if
okay.
it's going to make any difference or not.
Okay, yeah. No,
It
thank
might
you.
make just
I did mess that up.
yeah, might
Thank you
just
for
make a
correcting
tiny
my math.
little difference. Yeah.
Yeah.
Yeah. Okay. Well, this is good. Yeah, this is good. Is this the checkpoint you wanted to get to?
Yeah, I wanted to just get to this points,
Yeah.
and then we can get into more of the aggregations and some of the other things, sort of the next one, as well as,
Yeah.
building out more or less the same thing for the other graphs, and then how do you work them all together, as
Okay. So what you're going to do, you're going to do the aggregation of those 3 cities,
Mhm.
and then to get the average of those, and then
That's right.
that's going to become your top chart on this scene.
That's right. Yep.
Yeah. Okay.
That'll be our
That's
top
great.
chart, and then we just build the next ones and start to piece it together.
Yeah, this is great. Okay, good. Yeah,
All
okay.
right.
I think this is a really excellent a technique, Michael, to demonstrate the kinds of things that you would go through in building this flow from scratch.
Yeah.
Yeah.
Yeah. No, it's I think it's gonna be fun to revisit too some of these flows and
Yeah.
reimagine them inevitably along the way, sort of. But yeah. Anyways, all right.
Yeah, I
Good
think it'll be a
stuff.
good learning process. Do you still have recording going or have you flipped it off?
I need to turn it off. Give me 1 second.